the quarter of the semester of the calendar year. It's the last new stuff. It's so sad. It's so sad. Were you scared? Were you guys so worried that I was quitting? That would have made you so sad. How am I supposed to go on? I know. Okay. No, good. Yeah, this is it. This is the last time I have to teach you something new. And there's not much new in this. Shh. So what does the rest of the week look like, which is just one day? Tomorrow, I typically have guys, let's stop talking. You should have your notes out, page 138. I usually have a lot of absences the day for Thanksgiving, whatever. If you're here, it's a work day with nothing open in AP Classroom, but there will be a homework check tomorrow. So you can use the class period. Whoever's talking, please stop. Tyler, you guys. So you can use the time to work on anything. If you didn't finish it before the homework check, you can ask to go over what you got wrong on the quiz if you got anything wrong, because the quizzes are now in focus. Some people forgot to do it, so hopefully that's their dropped one. But anything I can do to support you tomorrow, you missed a day and you have some questions about something or whatever, guys, please use me on those work days. I always have something I can do, so I do something. I'm always up here working. But you guys are my priority 100% of the time. So if ever it looks like I'm busy, I'm never too busy for you, okay? So tomorrow and any work day, you missed this day, or you were here and you still didn't understand some stuff, bookmark it some way in your notes so you know when I have a chance or she has a chance, I need to ask her about this. But if there's anything I can do to support you, those work days are great days to do that, okay? So that's tomorrow. So if you're absent tomorrow, you won't miss anything but a work day, but a homework check, but I'll check it when you come back from Thanksgiving break. One other thing is that I will have your test reviews ready for you tomorrow, right, Nikki? Because you brought them to me yesterday from Coach P. But anyway, I have your test reviews ready, so I'm going to offer it to you tomorrow. If you want it early, take it or not, up to you. But if you have nothing else to do and you want to get started on it, you can. After Thanksgiving break, Monday and Tuesday are test review. Wednesday, Thursday will be tests. So you technically have 3 days for the review, 2 of them after the break. Okay? That's it. All right. And then we'll just review for exams and do the exam. Okay. So, guys, listen. We are being asked to graph a parent function, log base 2 of x, and g of x, which has log base 2 of x to the squared. So what we're going to be doing is graphing both of those. And this is going to be very painless. Make sure you have your calculator, though. And I'm hoping that when you see that squared there, it's throwing you off. Every time we have looked at any logs, and I think it was it yesterday or the day before, we did all the transformations, like when you could have a number in front or the parentheses and the number at the back and the flips and all that stuff. We have never seen a squared in a log, okay? That should be a red flag to you, that shouldn't be there. So what they're telling us to do is just apply the power property. Remember how hard that is? You bring the 2 to the front, okay? So if I move the 2 to the front, I'm not breaking any rules. Because of the power property, I'm allowed to do that. And now suddenly it looks like a normal transformation that we would do in any function, and that is a vertical dilation by factor of 2. Okay? So here's how you're going to graph this. We're going to use our calculators. We're going to make our life really, really simple. And let's start, well, actually, I'm not even going to use my calculator on this one because this one's too easy. To graph my parent function, remember, log base 2 of x, we always have an x-intercept at 1, 0. We're always going to have that asymptote at x equals 0. And because, I am going to put this in my calculator. I'm sorry. So I'm going to put it in my calculator. Sorry. I just spent my entire lunch and planning meeting with principal and the APs about the math schedule next year. So I'm a little off. Sorry. All right. So I'm going to put the parent function in my calculator just so I can get a few good points. And it's good practice. So remember how to type log base 2x in. You're going to use math alpha math. And that way you can have a spot to put in your base. I'm doing f of x. So 2 and then x, right? Now, here's what the picture looks like. Great. We know what it looks like. And so go to the table and find some friendly numbers to graph. Like, let's just pick 3. So we did 1, 0, maybe 2, 1, and 4, 2. And that's good enough. There is f of x, which is the parent function, right? Log base 2 of x. Now, what's going to happen when we do a vertical stretch, vertical dilation by factor of 2? Well, what that does is it takes the points from our parent function, again, 1, 0, 2, 1, and 4, 2. And what we would do is, or does somebody know, what are we going to do to something in here? Somebody tell me what I should do. Anybody? Do your best. Very good. I like that. Anybody else have a suggestion? Try. No, for real. What do we do to our y values when we have a vertical dilation of 2? We multiply them by 2. So if I multiply all my y values by 2, I stretch the graph. It's that simple. So my g of x would look like this. 1, 0, 2, 2, 4, 4. And then you could just sketch it like that. Okay? So the whole point of what we just did is we took something that was very unfamiliar and would be very hard to graph without a graphing calculator, and we changed it, used the parent function, and then just did some very simple math to stretch it. Okay? So guys, a number right after the equal sign is a vertical is your y values, dilation. So whatever that value is, you're just multiplying the y values by that. That's all that is. Okay? And then describe the change. This is just using your varsity math words that I just said a second ago. It's a vertical dilation by factor of 2. And we're going to add just one more thing because in your homework it's asked of you, and that's to do the XY rule. So let's just make sure we get that. Remember, an XY rule is saying, what am I going to do to my parent function's points to get my new points? What did we do? Nothing to the x's. We multiplied the y values by 2. So that's your XY rule. Okay? We're going to go over to example 7. Any questions on example 5? Okay. So question 1 and 2 in the homework are just like this. Okay? Let's do some work with natural logs. So it's asking for, so given f of x, find the domain, graph, blah, blah, blah. Analyze it. Tear it apart. Just state anything you can about the graph. As I've said to you many times, anytime I need to find the domain, the range, limit statements for end behavior, it's easier for me to have the graph first. And since we have to graph it anyway, let's just start there. And I am going to use my calculator, and I'm just going to put this whole thing in, okay? So -2 natural log x plus 1. Make sure you know how to type these things in the calculator long before test day, okay? Let's see what the picture looks like, okay? Now, by the way, the reason that it doesn't keep going, like it happened on the last one, and I should have kept it up, but like if you remember when we did this one, it kind of stopped right here on the graphing calculator, and we put arrows on the ends because we know it keeps going. Where did the rest of the graph go? No one's really asked me that, but maybe you just assume what is right. It's just that, you know, our calculators have limited capability with how small they can make the point. It's telling you it got so close to an asymptote that it can't even make any more points. There's an asymptote there. We should know that it keeps going, okay? I tried to sound like I knew what I was talking about and said it's like a pixelation or something. Like, I don't know what it is, but think about it. It can't, just like we humanly can't get any closer than our pen point, really, the calculator has its limitations too. All right, so great, that's what it looks like, but I'm going to go to the table of values and pick some friendly values. So if you remember, when I graphed natural logs with you one other day, we found that natural logs really only have one nice point. The one we did before, we had lots to choose from. We just picked 3. This is normal, okay? You could scroll. You're not going to find good numbers. We'll take whatever numbers they give us that are friendly to graph, okay? And from this table of values, I can see that I'm going to have a vertical asymptote at x equals -1. That should make sense, guys. This is left 1, right? So your asymptote went from 0 to -1. And then back to the graph, I can finish the graph nice and easy by just looking at this picture, right? I can say, okay, it's a decreasing function, arrows on the ends, etc. Okay? So there is the graph of f of x. We did it. Now, domain, range, asymptotes, all the other stuff. Domain, -1 to infinity, right? -1 to infinity. How about the range? All real numbers, Keegan. Asymptote. Don't you dare say -1. It's not -1, it's what? X equals -1. Okay? Just making a point here. You don't have to write VA or HA. I usually do just to remind you guys. But you have to put the X or the Y if it was horizontal. Okay? Really important. We've been talking about that as far as like tests and stuff like that. FRQs. Okay, intercepts, we got one right there. That's at the origin. Now here, this is kind of general. I mean, what do you want to know about it? Okay, concavity, we know concavity. That would be concave cup. Okay, how about this? We talked about it again recently. What about the AROC? Is the average rate of change between any 2 points, are they increasing or decreasing here? Raise your hand if you think it's decreasing. Raise your hand if you think it's increasing. Your hand is up, you are right. Increasing. Remember, and I'll come back to why, because I know what you're thinking, but the function is decreasing, okay? The function is decreasing. Remember, so decreasing means all of these slopes would be negative, right? Between any 2 points, they're negative. We're falling as we go left to right. Function is decreasing. But if you did find the slope between a bunch of points here, as you move along here, you would notice that the numbers were getting bigger. They're increasing. They're still negative numbers, but they're bigger negative numbers as we go left, right. And that has to do with the concavity. Remember, concave down is decreasing. Remember the D? So you have to remember AROC increasing or decreasing goes with concavity. Unfortunate that we use the same words to mean two separate things. That's why I keep trying to get it in your brain, okay? And let's do our limit statements. The limit of f of x, and everyone should be really paying attention to how you make your limit statement. I'm marking it wrong. You're losing points on FRQs if you're writing it incorrectly. So no more excuses. We should know how to write limit statements. You can do left or right first. I'm going to do left. So as my x's head to the left, they're getting blocked, right? Normally, there was no asymptote. We'd go to negative infinity if we're going left, but we can't here. We're going towards -1 from the right. But the y values are increasing without bound, meaning going towards positive infinity. Okay? And then our right end behavior. So looking at your graph, we're going towards positive infinity, nothing blocking us. And our y values are decreasing without bound. In other words, going towards negative infinity. Right? So pretty simple. Let's just do one more, and then I'm done. That's so sad. I like teaching. I'm bored on work days. Okay, so let's go back up to y equals. Everyone should be doing this, not just watching me. Oh, wait. Do you see something weird here? Let's fix it. We shouldn't have a squared on there. No big deal. We can move that 2 to the front using our power property that we learned yesterday. And now let's put this in the calculator. 2, Logan, are you paying attention? Put your head down. 2 natural log 3 minus x. We're typing it in our calculators. Let's see what it looks like. Oh, okay. Let's go to our table of values and see what we see. I see a nice friendly point at 2, 0. I'll start there. That's the only friendly point, fine. Where's my asymptote going to be? 3. Yeah. And then again, using the picture, I can finish this, right? So it's going to look something like this. Not exact, but that's okay. We're not making exact graphs in this class. We're mostly analyzing them. Okay? So the domain. What's the domain? Does the order matter here? Yes. Okay, and that's another part that I've seen students messing up on. Look at the picture. That's negative infinity to 3. Interval notation, which is what this is, has to be least to greatest. Has to be. There are teachers in this world, because I've had conversations with them and begged them not to do it, there are teachers in this world that say it doesn't matter. That is 1,000% incorrect. It 100%, 1,000,000% matters. It always, in every course, is least to greatest. It follows what the graph does. We read a graph left to right. We read interval notation left to right, okay? So it's not just me being particular. That is what the math gods dictate to us, okay? All right, we already graphed it. What's the range? All real numbers, right? It's always going to be all real numbers for this. And of course, we have an asymptote at, I heard the x, thank you, x equals 3. Right? The only new part of this lesson, and it's not so new, is going to come up in part D here. State any intercepts. Okay, we have 2, 0, right? Clearly an intercept. But look, guys, there's another one right here. What the heck is it? Okay, it's 0 something. I heard that. That's really good. But what exactly is it? So here's how we handle this. I'm going to be honest with you. It's always going to be some crazy decimal on a natural log. You saw all the points in your table. We only had one friendly point. So how do we figure it out? We go old school and plug a 0 in for x and solve for y. Very simple math, guys. If I put a 0 right there, I get 3 minus 0 is 3. And if I put that in my calculator, you get like 2 point something. So I could easily type 2 ln 3 and get an answer. But what we're going to do is leave it in exact form. Just leave it like that. We know that that represents a number that we could find on our calculator, but we would have to round it. Okay? So 2 natural log 3 is 2.19. Blah, blah, blah. So that's a rounded answer that we would write. This is called an exact answer. Let me remind you of another time in your life